So question 2, an impatient businessman paces up and down while making a business call on his cell phone, right? So he's here, he's pacing up and down. He starts at his desk and walks 5 meters east. So that's east, he walks 5 meters, that's A to B, and then walks 7 meters west, that's B to C, right? And then this process takes 20 seconds. So the whole thing takes 20 seconds. Use a vector scale diagram and represents the two displacements of the man from A to B. So I'm using a vector. Remember, there's an arrow. There should be an arrow when you are doing a vector. So A to B. So that is my A to B. Right? So there you have A to B. I'm not going to draw everything to scale, unfortunately. So A to B, and from B to C. So let's go B. This is B. From this point here to, let's say, yes, let's say this is C. Label all the vectors clearly and write down the displacements next to the vectors. So apparently it's 5 meters to the east and then 7 meters to the west. 7 meters to the west. So that's my vectors. Yeah, I believe that's it. Now use a vector. What is the businessman's change in position C relative to A? So what is the change in position from this point to that point? So this is not, so from this point to that point clearly is the difference between 7 minus 5, which gives you 2, right? So that's your 2. Businessman's change in position from C to A is 7 minus 5. 7 minus 5, which gives you 2. And then calculate the total distance the man covers. So that is clear also that the total distance should be 5 plus 7. And it should give you 12. So once you've done this, you then explain why the value calculated in 2.2 differs from the one in 2.3. Now 2.3 talks about total distance. It's the total distance. It's the total distance. Whereas 2.2 talks about displacement. So once you are at this point, you are almost done. Calculate the man's average velocity. Now, what do you need to calculate velocity? So V is equals to, what is velocity? Now, what do you need to calculate velocity, guys? So what do you need to calculate speed? Speed is equals to d over t, right? Something like this. So apparently the distance that he has covered, according to this, I'll look at it from a displacement point of view. So I'll say it's 2 over, and then I'll go t. Remember, I took the displacement instead of taking the total distance. Now, because they want the average velocity. So for t, I know the time is 20 seconds. So I'll put in my 20. There's no conversions that need to be done. Therefore, v is equals to 2 divided by 20, which is 0.1 meters per second. Right? That's the velocity he was traveling. So this is your answer for this particular question.